welcome back to Dozzy's Television Workshop, where today we're finishing off this Radiola RA248. Let's get into it. Okay, so while that's drying, we'll attend to this. So, can we get the dial glass off easily without wrecking it? How is it fitted? Sometimes they're just on rubber grommets. We've got to be very careful because, you know, this rubber is now of some age. And, yeah, it probably won't take very kindly to being tugged about too much. Yeah, it is. It's on these rubber grommets. I choose not to do that. I choose to get a bit of Mr. Muscle window cleaner. And we'll clean the glass up there. We'll get that on-off switch, bit of a birthday. Maybe that sort of plastic effect speaker cloth as well. Get it all in there. It's funny how that switches, because it's sort of flat when it's off and then on like that. You'd expect it to sort of go both ways. I suppose it's all part of its aesthetic. Yeah. Right, let's lean it on its back a bit and just get this final bit of glass cleaned up. That is looking a lot nicer now. Let's get the brush in the grill. See all that stuck in there, coming out horrible. Wouldn't be too difficult really to unstaple it, but again, I do wonder how fragile that is. I'm not going to particularly go mad with it. Try not to get the speaker cone exactly soggy. Right, other jobs we have to attend to is this bit of gaffer tape bodgery going on here. I'm going to vote for a little bit of zip tie bodgery instead. So I think I just need to snip through that. What am I going to use? Let's use a scalpel and just trim that away. Yeah, it's not very nice, is it, really? Where's those nasty tweezers I got free with something the other week? 47 mic, 450 volt. Diagram called for 50 microfarads, so it's exactly what I'd have fitted. How am I going to get that off? I need another pair of pliers, really. Yeah, let's just get in on there. Grab all of that and try and peel it off that way. Whoever did this did a cracking job of shoehorning the damn thing in place. Surely it would have been easier at the time to use a zip tie than to do a bodge with some gaffer tape. Okay, well that's what was in there. Don't like that. The repair's actually alright, there's nothing wrong with that. But yeah, don't like the stickiness at all. Right, box of zip ties. Okay, let's see what we've got long enough. Oh, some nice long ones, look. I reckon that'll probably do the job. Use these nasty cheap free tweezers again just to guide the end into where I want it to be. Oh, bit like threading a needle. It's a much tidier, safer all round kind of a job. Snip the end of that zip tie off. I'm pleased with that. That's good. Right, so we're in a much cleaner state. We've sorted out our mains power supply so it doesn't blow itself from here into the middle of next week. Just put all the valves back straight. Now, this capacitor on the output bothers me slightly, but it's a Philips and it looks to have been done previously. I will just check that for leakage, because it might be alright, it might be rubbish, but yeah, it's been changed previously. This is either on the input or the output of the power output, speaker output transformer. So yeah. Oh, it's a very Philips looking transformer, very modern looking. Okay, we'll need a meter. We'll want ohms. We'll just see if that's leaking at all. Well, the answer is sort of yes. It's falling as it charges. Let's get a couple of those little crop clips and just hang that on there for a minute. This is when Odge-Nodge's AVO comes into its own, because they do measure a little bit of current. Have I got another one there? No, right. Well, was I holding on to those leads or something? Because that's perfect. Now look, that's meg ohms. I think we'll be happy with that capacitor, and we shall put him back home. Right. Okay. We're all good. I'll tell you what, while I've got the clips on the leads, let's just measure the actual current consumption, shall we? So I'll choose milliamps. Milliamps AC. What I'll do is I'll just pop the fuse out. Just to see if we've got a sensibly rated fuse. I don't want this coming back, you know, with a blown fuse in a couple of weeks, just because I got it wrong. It was a finger in the wind guess. So, yeah. Right, straight on with 240 this time, no messing about. Not a lot of milliamps. Actually, why isn't that coming on? Ah, haven't switched it on. There we go. Makes all the difference. "85 milliamps, 86. Here we go. The valve's warming up now. I expect. So there we go. Awful interference from the cameras and everything in here. So let's just let that hot up. Yeah, I mean, look at that. 120 milliamps, 130 milliamps nearly. That's strange. As you turn the volume up, the current consumption falls. How strange. Anyway, that's good. Capacitor's fixed. Yeah. That's all good. We're not consuming much in the way of current. So, yeah, the next thing to do is I'm going to have a look in the service sheet and see what the alignment procedure's right. Although, if you've seen the little coming soon video I did a few weeks ago, and actually very few of you have watched that, but there you go. It was about this. You heard it playing Radio Caroline on 648 kilohertz here. And let me tell you now, that was quite remarkable for me, because yeah, that reception is terrible here in my location. I don't have very good ground here, and yeah, medium wave really suffers. But yeah, it was doing a very respectable job, I thought. So good. Right, we're in a safe condition. I'm going to zip over to the schematic and look at that, and then maybe have a look at aligning this. And I will show you the procedure, if I'm going to do it, if I understand the service manual. But I can't do it with the cameras running, because they make so much RFI, I won't know what I'm aligning to. So yeah, I can't show you that unless I get a camera that's quiet. Even my phone makes a row. So yeah, sorry about that. But I'll talk you through it. Let's go and have a look at that schematic anyway and see if we're going to bother. Right, we've got the service sheet up. Circuits MF, so this is medium frequency. We want PO, that's medium wave, and we want to set the index at 1500 kilohertz. Turn the volume to maximum. Voltmeter across the things of S16. Is that this? S16 points to connection. S16. Okay. Signal of 455 kilohertz at G1 and L1 at mass. Does that mean maximize it? S12 and S11. Verify the... Oh, I don't know. Right, don't touch it. Okay. Circuits HF. Okay. Vindagam. Gam. Oh, maximum to sortie. Let's just scroll down and see what we've got listed here. So we've got a 6 megahertz coil. Now that's obviously for shortwave, and I'm really not interested in shortwave, and I don't suppose Jonathan is either. But we've got C6 here, which I think is a little... So we've got the speaker transformer here, so the speaker's at the front. C6, which is a trimmer. C7, and we've got these frequencies listed: 240 kilohertz, 525. Right, these are our 455 kilohertz IFs. G1 at L1 en masse. Right, so what is G1? First grid of one of the valves, maybe? This is going to be a challenge, isn't it? Where's our... That is the wrong way around. Anyway, right, let's just have a look. So here are your F transformers, L2. So they don't refer to the L2 filament, and they refer to the grid as a grill, not as a grid. So G, grill, maybe? We certainly want to inject our IF in here somehow, and then peak these transformers. We could just couple into it. That might be a way to do it. So, volume to maximum, voltmeter alternative. Bonds to S16. 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 S9. S2. What is S16? It's not across the speaker, is it? These are all called S's. These are called S's. Here, look. So what is S16? S4, S5. S16 is going to be a coil. S9. C32, C33. Those are those original caps that have been changed. Across S16. With no reference to what S16 is. Oh, hang on. S16. 200 picofarads. MF1. Here we are. 200 picofarads. Oh, that's C16. There isn't an S16. S12, S13, hang on. S16, Hort Parlour, the loudspeaker. So we've got to put a signal in, voltmeter across the loudspeaker. Why don't they just say that? Signal of 455 kilohertz onto G1 of L1. So we want to put a signal into L1's grid. Right. Grill. So L1 grill, which is that one there, which is straight off the top of S5. L1's grill. Hang on, they say G1. So L1 obviously has two grids. Which grid do they mean? Do they mean this grid or this grid? Or some of the screen grids? Screen voltage, no. L1, G1, grid 1, pin 1 maybe? What's pin 1? That's the second grid in that tetrode section here, multi-electrode section. How many have you got? 1, 2, 3, 4, 5, 6, 7. Blimey. Oh yeah, we're two connected together. It's a pentode. Right. Would you want to put 455 kilohertz in there? It's going to break through anyway. So, let's have another quick read. Signal 455 kilohertz enters G1 of L1 et mass. Don't know what that means. Bezier, the maximum Lesnoyo voltage, I think, of S12 and S11. So at this point, I'm just adjusting S12 and S11. S12 and S11, which are there. So those are some of the IF transformers. I don't know what that means. S13, 12, 10 and 11 in that order to peak it up. Right. So I can do this with the cameras on, because we're going to be injecting a signal. Let's have a go at it, shall we, and see what beckons. If we don't get any noise out of it, because I can modulate a 455 signal, I wonder if that's what they mean. Mass, modulate, I don't know. Let's have a go at it. Right, I'm all set up. His lead here is supplying our 455 kilohertz signal. We've got about 4 or 5 millivolts. It's actually feeding that 330k resistor up behind that valve, which is the first grid. I've got the meter here connected across my loudspeaker. We've got to start with, let me look, maximum S12 and S11. This one here is S12, this here is S11. Now these are brass slugs rather than the usual crumbly ferrite ones. We haven't got much of a worry, so we're going to power on. Let's just wait for that to warm up. Obviously I've popped the fuse back in, by the way. So yeah, there we go. We can hear our test tone, so that's nice. And now we've just got to peak it up. Oh, that's getting better straight away. See our voltage there. We did see 133. 134, 133. Well off there. That's about what we're going to get out of that, is 130. So then we come over to this one, we'll peak that. Wow. Let's turn my drive down a little bit, I think. That made a lot of a difference. Then we've got to go 13, 12, 10 and 11. So 13 is S13. That's the top one over here. Let's turn our drive down a little bit more. I can't, that's on minimum. Good Lord. My goodness. Did I just see 560 on there? I did. And that's about our limit. Well, that's made a great improvement. And one I'm going to relish turning the volume down on. There we go. So that's, well, that's made a hell of a difference. So for the next thing, I am just going to get some of my favourite Rimmel nail varnish. And I'm just going to dab that on there, just to seal them in place. And now we're going to go back to the service manual and see what the next step is, which I think will be aligning the front end. Let's get on that. So that's our IF circuit aligned. Circuits HF, condensator variable, so that's our variable capacitor to minimally meshed. Your index should then be, I don't know, on the mark of 1620 kilohertz. Okay. Antenna fictive, so a fictional antenna of the generator enters at the antenna socket. Okay. Reprendre le réglage. Okay. Adjust the regulator maybe of C6. Avoir. What does that mean? With introduction the chassis into the coffret, fin the compensator, the action, the bindage. It's embarrassing, isn't it? Typical bloody British engineer has no grasp of what's going on. I am just going to wave the magical Google Translate app at that and see if it can make a better job than I can't. Right, where are we? Google Translate on my phone. Resume the adjustment of C6 after inserting the chassis into the box because of the compensate for the action of the shielding. Oh, right, where is C6? C6, 1620 kilohertz, under here. Okay, 1620 kilohertz. How are you meant to get at that? Oh, I see what they're saying to do now. Oh, no, it's not. It's a little... Yeah, all right. Okay. Yeah. I'm going to adjust it, and then we shall slide it all back in the case when I've got the case back together. So let me just power down, because my signal generator has now got to go into my artificial aerial socket. Right, well, I found C6, and it's a beehive, which is a capacitor that's got two sliding sections that go in on a thread. Really nice, typical Philips. However, the one end of it is the bed you normally adjust is soldered to the chassis. So the only way to adjust this is to turn the whole thing. Now that's all very well and good, but yeah, that gives me a slight problem, because they've put it on a flying lead, so that's not bad. But how on earth am I meant to do that when it's in the chassis? It's going to affect the frequency alignment, probably not significantly. So let's just peak it up and see where we get. So my frequency generator is set to 1620 kilohertz. We've got a bit of modulation on there. So let's power the radio up. And again, I've got my meter back across the loudspeaker. The vacuum variable is not vacuum variable. The variable capacitor is on minimum, so I can't hear the modulation there. I wonder if the tuning is a bit off. Well, let's just adjust that round a bit. I don't know what it's connected to, do I? Do I want to grab hold of it? Probably not. Let's use something insulated, shall we? Right, I have donned a glove, because that is our capacitor I've got to adjust. According to the service manual, there are actually two, but that service manual is a bit flaky. And these are beehive type capacitors, so you have to rotate the housing. And I haven't looked at the schematic to see where it is. It might have HD on it. I doubt it, but I don't want to go touching it. Now, it did say to make sure this is in the case. Well, that's a little bit interesting, because there's no way I can adjust that whilst it's in the case. Anyway, let's just peak it up. That's definitely less signal. .564. You can see it heavily affects the reading as I'm getting near it. I think that's my meter probe affecting the speaker. 590, let's go a bit more. 612, that's less than it. No, 620. 617. 618. 620. 620, I think we're in the peak there, aren't we? 620. Oh. 620. 620. And this is the other one here. So I'm just going to see if I can get in there. Just hear me being even in there, just... That's just noise and rubbish now, isn't it? Wow. $6.25. It's as good as we're going to get there. Switch the signal generator back off. Let's see what it says about anything else. Scalanoia, yeah, that was a bit about the cabinet. And then it's just about voltage. So, yeah, there's a 525 kilohertz adjustment on the top next to L4. I wonder if that's for the other end of the scale. Which would be right, wouldn't it? 525. So let's put my signal generator back on, and we'll have it on the other end of the dial. So let's see if that lines up roughly with 525. So 525 kilohertz, modulation 100%, 1 kilohertz, modulation on. Ah, yes. Okay, so let me just turn down that amplitude a bit. There we go, slightly noisy so we can do it. I'm just going to power off as I move the thing. So L5 is that thing full of goo and nastiness in there. So I don't know if I can get in there with this. That's been sealed up. Do you know what? It's loud enough. I think I'm going to stop there and call it a win. Right, take my artificial antenna off the way and switch my SIGGEN off, otherwise that'll be interfering all over the place. And let's just see what our reception is like now. So, yeah. Now, bearing in mind all the lights and everything on it, in fact, I'm just going to dim this light down because that's PWM and it really is awful. So, it does sound a little quieter actually.
To fake or rather that we're going to get the latest from Betfair, the official betting partner of TalkSport's Premier League coverage.
Pretty good. It's receiving well. It sounds good. So it probably wants a little bit of an aerial on it, and we'll get all sorts of weird and wonderful stations. Even just a short length of wire would definitely help in this instance. And I'm really not surprised that we're not getting much at the top of the band, because in here the noise level is just horrific. Right, let's go and see if the cabinet's dry. Okay, it's the following day. The case has dried out. There are a few sort of stains on it that I can't shift, and there are a few scuff marks and what have you, but certainly looking a lot better than it was. So yeah, quite pleased with that. The inside, by the way, I noticed that there was a label in the top of the lid here, so I've been a bit, I've not scrubbed that as clean as I normally would, because I did want to preserve that label in there, which just shows you where all the valves are. So yeah, I haven't gone mad on it, but the outside's come out quite reasonably, I thought. All the foam pads, felt pads here, have stayed in place and are still very well adhered and nicely dried out. So we'll just lower the chassis back into the case. Making sure we get it aligned right. Yeah, that's not right. There we are. Okay, now there's long screws at the top, short ones at the bottom. So pop those in place. Again, there's no holes at the bottom or anything. We could adjust those two capacitors. I suppose you could keep putting the case on and off when you're adjusting for 1625 or whatever it was, but yeah, just does seem to be a little bit of a thing. Right. Mains lead needs to go through the back cover. Before I do that, let's refit these knobs. The knobs, by the way, I did clean up off camera, just with a bit of soapy water, and they did come up absolutely beautifully. So that is the wave change switch, by the way, with a dot on it, and it's also got a cutout which locates into the wave change selector mechanism. So let's just put that one on first, make sure it's engaged, which it is. I don't believe there are any difference in the two outer part knobs, which in fact there aren't. So let's pop. Are they different diameters? Oh, they are. There is a difference. That was never going to go in the other way around, was it? Is our tuning scale working? Now, outer concentric for the tone control, and the final outer knob. Interesting to know there are two different sizes of grub screw as well. This one is a smaller diameter. That went unnoticed when I took it apart as well. That's lovely. Right, final operation check. So that's power on. Marche. Dial light's looking a bit happier now we've given it all a bit of a birthday, so that's good news. We're on medium wave. Yep.
Clean through, one-on-one. That is a majorly...
Okay, still working, so that's good news. We shall disconnect the mains lead. Now, one thing I do want to do, just before I put the mains lead back in, really it wants to be a double insulated thing, but it's in good condition. I'm just going to put a stripe on the one that's electrically closest to the chassis. So yeah, let's just clip on a bit of chassis there. Meters at ohms. I don't think it was a dead short to chassis, but it's where the neutral ought to end up, really. It is an auto transformer after all. That way, ohms we want. That way is open circuit. We're not switched on, are we? There we go, switch on. Many kiloohms, and on this one, yeah, 280, 289, 288 ohms. So that one ought to be on neutral. So I shall just mark that with a bit of Sharpie so I know which one it is. There we go. Back panel. Mains lead through the hole. Pop it down on its front, I think is probably easiest. That wasn't like that before, was it? I suspect that's how it is supposed to be. There we go, that's snug in there. that's it. One thing I do just want to check is that none of these screws are actually coming back to the neutral, because we are missing one of those caps. So, worries me a little bit. No, they're all isolated. I thought they were. The mounting brackets are plastic. But obviously the neutral being still considered to be a live conductor, you shouldn't have any of that exposed where we can touch it. And we haven't, so that's good. I shall put in the 3 of the 4 plastic caps that were there. There. I think that's turned out very nice. Let's put the plug back on and listen to some radio. There you have it, the Radiola RA248, now aligned and performing really nicely. Thank you for watching. Click like, subscribe, do all that rubbish, and buy me a coffee if you want. There's a link in the description below, and I'll see you really soon here on Doz's Television Workshop. Cheers now, bye. that's about all we've got time for on this week's DOS Television Workshop. It's coming along nicely. Join me next week when we'll be going through an alignment and reassembling the receiver. Mes excuses pour le mauvais français, mais s'il vous plaît, cliquez sur j'aime et abonnez-vous et la jour verrai, and the bloody phone's gone off. And I'll see you next week. Mes excuses, no. Mes excuses pour le mauvais français, mais s'il vous plaît, cliquez, s'il vous plaît. Mes excuses pour le mauvais français, mais s'il vous plaît, cliquez sur j'aime. Mes excuses. Let's listen to that again, hang on. Mes excuses pour le... My old boots, really? Me, I can't read it. Poorly.